All right, let's have a look at some different types of mechanisms that we'll use on our robots. Common mechanisms. We've got our drive systems, intake, indexing or handoff of the game piece, elevators, arms, grippers or scoring mechanisms, shooters, and climbers. Drive system. This is basically what makes the robot move. So being able to travel across the field is the most important feature of your robot. If you can't move, you can't do anything else. The most common method for this in modern FRC is via swerve drive. We will likely be a swerve drive robot this year unless we have a reason not to be. And most robots essentially look the same at the drive base level. The picture here is probably what a drive base looks like for the majority of robots out there. So 4 swerve modules, one on each corner of the robot, some tube in between, and then some structure that holds it all together. And that is basically your base that you build everything else on top of. The intake. Intake is used to collect game pieces from the floor. Most games that we play involve picking up stuff off of the floor. Typically this is going to extend and retract, as anything outside of the bumpers is in danger of being damaged by other robots during collisions in match play. So this is an intake here, and you can see this is on a pneumatic cylinder. So this would rotate up into the robot and then come down when you want to pick up pieces. This looks like it has spinning rollers. So you would drive into pieces, these rollers would spin, part gets collected up into here. That is basically what an intake would be. Intakes generally all work pretty much like that. At the beginning of a match as well, we should note the rule has typically been all mechanisms of your robot must be inside the frame perimeter at the beginning of the match. So everything needs to be capable of going inside the frame perimeter of your robot for start of match. Indexing or handoff. This means getting the game piece from your intake to the scoring mechanism. Okay, so once we pick up from the floor, we have to be able to get the piece from our intake into our shooter or whatever the scoring mechanism is. This is what we call indexing or handoff. This is typically a very difficult process. You have the potential for things getting jammed or stuck. It is especially difficult when you are capable of handling multiple game pieces at one time. An example here, as shown in these pictures, this is from 2020. You could actually carry 5 game pieces at a time, and these balls, which are called power cells, they had a very tacky surface to them, and they would stick together kind of if they rubbed against each other. So trying to handle them inside the machine was difficult because they just didn't slide off of each other. They would actually kind of bind up, which made it really difficult to work with. So the index and handoff process is a difficult one. It's also something traditionally we have not been good at. An elevator. Elevator, pretty straightforward. It basically lifts your scoring mechanism or intake or whatever it is you're trying to lift. Goes from a low level to a high level. Lots of different ways to do this. We can build them in different stages as well, single stage or multi-stage. You can actually buy complete elevator packages as well. These ones over here, this would be like a single stage elevator here. This one would be a multi-stage, so it's got multiple pieces to it. So these all move together to go even higher. And you can get pretty tall with elevators, as we saw like in Deep Space had a lot of elevators that went up very tall. Power Up used very tall elevators as well. Arms can get very tricky and very complex as well. Used to either extend upwards or outwards. Lots of different configurations for arms. They could be a single jointed arm or a multi-jointed arm. This is our 2023 robot. It was a two jointed arm, so one pivot here, one pivot down here. So both of those move together to be able to extend out and then fold back in. A pink arm is a telescoping form of an arm. 4039 used a pink arm in that same game. So you'd see their arm would pivot here, and then this entire arm telescopes outwards. So it's capable of extending outwards and then angling up and down, and that's how they would work their arm. So that's called a pink arm. And then looking at scoring or gripping mechanisms as well. Lots of different ways to design this. Typically you need to be able to deliver your game piece very fast, very accurately. In some games you have to be able to handle multiple different types of game pieces. So for example, these pictures here again from 2023, we had two different types of game pieces. We had the cone and we also had the cube. So both of these robots here, examples of, we had a gripper that's capable of picking up both a cone and a cube as well, and 4039 did that as well. One gripper that would be common for picking up both the cube and the cone. Now 1678 very famously says rolly grabbers are the best type of things you can do for a gripper, which is basically you have lots of spinning grippy, I should say grippy wheels to make grippers. Is a way to grip something very quickly, to go in and out, picking up parts. You want to have spinning wheels that are grippy to do that, as opposed to what we are both doing here, which is a kind of open and closing gripper type operation. They suggest using spinning wheels that are grippy as a method of doing that. Shooters are another very common mechanism, especially in shooting games. You're able to shoot game pieces very accurately and with a lot of power. The hooded flywheel shooter is the most common thing we've seen now for shooting balls. This can be teamed with a turret, or just with a lot of robots just with swerve drive, are able to very accurately turn the robot and don't need a turret. But most of these as well now also incorporate vision guidance in their shooting as well. And with this hooded shooter, you can control the trajectory, power, and distance via the hood adjustment. So you can see these gears on here. So the angle of this hood, the more you extend it back, the higher your trajectory will be. The more you bend it over, the lower your shot's going to be. And then depending on how fast or slow you run your flywheel down here, will adjust your power of your shot. So you can control the trajectory and power of your shot, and you can accurately shoot over a long distance based with those two factors. That is a hooded flywheel shooter. And the last thing we'll look at here, climbers. A lot of robot endgames now have a climb at the end of it. Things with a climb, you have to be strong enough with the climb to be able to lift the weight of your robot, and you want it to be fast so that you don't waste a lot of time doing it. One important factor here is after you climb and the game ends, your robot goes into a disabled mode, which means you no longer have power on your climbing mechanism. So your climbing mechanism needs to be able to hold your robot even without power. So you may need some type of brake system or ratchet system that holds it in place. There's also been some games where you're capable of doing a buddy climb, and that means climbing with a second robot, or actually picking up an entire second robot to allow for some type of climb as well. So this is 2018 here, Team 148, the Robo Wranglers. They had a really good system where they could actually grab onto a second robot and just lift that second robot with them to basically get a double climb. No matter who they were climbing with, they could grab onto the second robot and just hoist them up with them, which is pretty cool to be able to do. That is called a buddy climb. So, some ways to simplify your mechanisms. Some different things you can do. One is by combining different functions together. So for example, if you have multiple game pieces, you can pick them up with the same mechanism. So example, being able to do cubes and cones with the same scoring mechanism. If you can do intake and scoring with the same mechanism, you don't require a handoff. So many teams in 2023 did this. We did that in 2023. We also did that in 2022, the Rapid React year. We had one mechanism that we used to pick up off the floor, and that was the same thing we used to actually deliver the balls into the goal. So we didn't require any type of handling or handoff or indexing mechanism inside the robot for that. So that does simplify design quite a bit, being able to do that, if you can do that effectively. And there's examples of being able to combine things together, such as climbing and elevating. So there's several teams in 2018, 2019 that had an elevator that also used that as their climbing mechanism as well. So because you're already moving in that vertical direction, if you can put a hook on your elevator and you can use that to lift your whole robot up as well, that is a possibility as well. And then another thing, reducing the capability of what you're actually trying to do. So if you're having an elevator, but you only make an elevator that goes part way up to complete some of the game tasks. So for example, there was some very, very successful teams in 2019 that could only score to the mid-level of the rocket. So for example, Jack and the Bot team in 2910 only scored mid-level on the rocket. They did not go to the highest level on the rocket, but they were able to simplify the design quite a bit by doing that. There was teams in 2023 that could not score on the highest level of the grid, I guess we'll call it, yeah, the grid, or they only did cubes. So by simplifying their designs and not doing all the tasks, they're able to greatly simplify their designs, but still were able to make very successful robots. Or only doing a partial climb. So for example, in 2022, we were able to do the full traversal climb, but a lot of teams didn't. So they did not try to go for everything, or teams that did not try to do the trap in 2024. 2056 had no interest in doing the trap in 2024 because they thought it was a waste of time and they didn't want to take away from other parts of the robot by trying to do the trap. So simplify your design that way. So historically, if we look at what 4903 has done, going from 2018 all the way through to 2024, can look at where we've had success with mechanisms and where we haven't. So one common thing you might see here is the two really good years that we had, 2023 and 2019. What did those things have in common versus the poor years? I guess one thing you could really look at, 2023, very few mechanisms. We had an arm, we had a scoring mechanism, and that was it, along with the drive. And we had a really good arm. It had like basically a world-class performing arm and a good scoring mechanism. But we didn't overcomplicate things. We didn't build a lot of other things. Compare that to 2024. We had an intake, we had an index, we had an arm, we had a shooter, we tried to do a climber. And none of those we did very well. So that's doing a lot of things and none of them working out very well versus doing only a few things and having them go well. Some other examples, we only did a couple of mechanisms on the 2019 robot as well. 2022, again, only a couple of mechanisms. We went and did a lot of things in 2020 as well. We've never been good with the index. Arms we've been pretty good with. Scoring mechanisms we've been hit and miss. Intakes, we've been kind of hit and miss. Climbs, we've always done pretty well. So historically, climbing, scoring mechanisms, arms, we've been pretty good with. Everything else we've kind of struggled with, and our drive has been pretty good. So that's kind of our history in a nutshell there, and that is basically mechanisms.